All right, let's finish up chapter 3. So solving systems of nonlinear equations just means you're going to solve a system of equations, but they aren't straight lines. So when you have a system of equations, you're going to use substitution. So if y equals x plus 2, you're going to substitute that in the other equation. So x plus 2 has to equal negative x squared plus 4. Then you have to just solve that equation. That's a quadratic, so you could add x squared to both sides, and you could subtract 4. So I think you come up with that equation. When you add x squared and subtract 4, this factors into x plus 2, x minus 1, so you get an x value of negative 2 and an x value of 1. But remember, when you're solving a system, you're looking for an xy pair. So now I have to say if I put in negative 2 for x, y equals negative 2 plus 2, y would be 0. And when I put in a 1, y equals 1 plus 2, y would be 3. So your ordered pairs then are negative 2, 0 is one place where they intersect, and 1, 3, the other place where they intersect. So that's just where those two curves intersect. You do the same thing over here, except for to get started, you would have to solve for one of these variables. So let's say I add x to both sides, x plus 4. Now you're going to take that value for y and substitute it in right there. So you have x squared plus the quantity x plus 4 squared equals 40. And now you have to solve that. Don't forget, when you're squaring this, you're multiplying it by itself. So you're taking x plus 4 times x plus 4 to solve that. So you have to FOIL things out. You'll get x squared. You'll get a 4x and a 4x, so that will be 8x, and 4 times 4 is 16. So when you multiply this, you're getting this trinomial. Equals 40. It's a quadratic, so we're going to add these two like terms. I have 2x squareds, I have an 8x. When I subtract 40 from each side, I get negative 24 equals 0. Now, you can use quadratic formula, you can try to factor. When I look at that, I see that there's a 2, like all of those are even, so I would divide out a 2. As long as you divide everything by 2, you're okay, because that's going to be a little bit easier to factor. Pairs of factors of negative 12 that add up to 4 would be x plus 6 and x minus 2. And then you get x equals negative 6 and x equals 2. Plug that back into any of these equations. You can plug it back into this one, or this one, doesn't matter, to get your y. So I'll let you finish that. Well, actually, I could finish it pretty quick. Negative 6, x equals 2. Plug it back in. Y would have to be negative 6 plus 4 is y would be negative 2 here. If I put in x is 2, I get y is 6. So I have the ordered pair of negative 6, negative 2, and 2, 6. Okay? So that's what they mean by solving a system of nonlinear equations. Okay, then we have inequalities in this section. Again, it all deals with quadratics. Oops, sorry. So one kind of problem is, can you graph an inequality in two variables? So this is going to be a little bit of a review of, do you know how to graph that equation? So this one's in vertex form, so you know that it got shifted 1 to the right because of that minus 1, and 3 down. So if I go 1 to the right and 3 down, there's my vertex. It opens up, so I know it's going to go in this direction. If you want to get a little bit better picture, you either can know that, okay, when I go over 1, I have to go up 1, and over 1 this way and up 1. And if you go over 2, you go up 4, so if you know that stretch, or just come up with some more ordered pairs. Put in x is 2 and x is 3 if you want to get a pretty good picture of what this looks like. It's a parabola. Now I'm dotting this parabola for a reason, because this is just a greater than. So I'm going to dot that, keep it a dotted line, and then I just have to decide, am I shading everything inside of it or everything outside? Now you can pick a point, like I could pick the point 1, 0, put in x is 1 and y is 0 to see if that's a true statement. I would get 0 is greater than negative 3. That's a true statement. So since that's true, that means everything in here is true. I shade that region. What I think of as well is, once I get into y equals, y is greater than means I want everything above, so I kind of know that I want everything above that graph. So sometimes it's easy to kind of think about above and below. This one, you first have to factor, because this one is in standard form. don't forget you always can take out an x. So now I see that I have a 0 at 0, and I have another 0 at -4. And again, if you want an accurate picture, realize that the vertex is halfway in between. That's where your line of symmetry is. So that's at x equals -2. And you could plug -2 back in. -2 squared is 4, plus 4 times -2. 4 plus -8 would be -4. So it is at -2, -4, the vertex. This one's a solid line. And again, you can pick a point. Let's pick -2, 0. So if I put in x is -2, I already know what I get. I get -4. So is 0 less than or equal to -4? No, 0 is bigger than -4, so I want everything below or outside. So if this isn't true, I have to shade the other side. Okay, so that's just, can you graph a parabola? Decide if it's a solid line or a dotted line, and then pick a point either inside or outside. Usually I pick one inside. If it makes it true, you shade it. If it doesn't make the inequality true, so when you put in a y of 0 and an x of -2, it wasn't true, so then I have to shade the other side. Okay, and then the last one is, can you solve a quadratic in one variable? So now we aren't really drawing a graph, we're just trying to decide what values of x make that true. So the first thing you want to do is figure out where does it equal 0. So I'm going to factor this. Pairs of factors of -28 would be -7 and +4, I believe. So that's where you drew a number line, and you said, okay, one of the roots is at 7. I'm going to open circle that because it's just a greater than. And another root is at -4, open circled. Then you just have to pick a point. Usually I pick something in between. So I would probably put in 0. All right, if I put in 0, is that a true statement? So let's put in 0. 0 squared minus 3 times 0 minus 28 is greater than 0. So is -28 greater than 0? No, it's not greater than 0. So everything in here would make that false. I don't want that. I want the parts that make it true. So you could pick some other points over here, but if this part makes it false, if in between is false, then I know on the outsides it's true. So it's going to be x is less than -4 or x is greater than 7. So pick a number in between those roots. If it makes it true, you're going to think of all the points in between. If it's not, you're going to think of all the points on the other side. So let me just try to do this one. Again, we factor out that x. So I get x. Actually, we can factor out a 3x if you want to. 3x, and I'll get x plus 2. If I set 3x equal to 0, I get a 0. So there's one root at 0. And again, this time it's filled in because of the or equal to. -2 is that root. Fill that one in because it's or equal to. I'll pick a number in between. So I'm going to pick -1. So if I put in -1, 3 times -1 squared plus 6 times -1, I want to see if that's less than or equal to 0. So -1 squared is 1, 3 times 1 is 3, 6 times -1 is a -6, so I get 3 minus 6, -3. Is that less than or equal to 0? Sure it is. So since that makes it true, that's a true statement, I want all the things in between those two. So what can I say? I can say -2 is less than or equal to x, which is less than or equal to 0. That's the easiest way to write that when it's in between -2 and 0. -2 is less than or equal to x, which is less than or equal to 0. All right, so that ends chapter 3. I'll work on the videos for chapter 4.